So suppose there are there exists n day in a calendar day, that means school calendar. Let's say you have 2 semesters, semester 1 and semester 2. So there are n day. And suppose there are k day in semester 1. So how many days in semester 2? N minus k, right? Suppose I am the head. I have the power. I said I put 1 holiday in semester 1. And I put 2 holiday in semester 2. Then question, how many possible way I can have this arrangement? I can have the first holiday in semester 1 is day 1. Or I can have the first holiday in semester 1 is day 2, and day 3, and day 4 until day k, right? But for the second semester, I have 2 holidays. I have any way to put inside semester 2, depending on this k. I can make my semester 1 only have 2 days, and then the remaining many days are semester 2, right? So how many ways? Again, you will know how to solve this problem after this part. Okay. So these are the motivation. So first, what is combinatorics? Combinatorics is just a fancy word of call counting. And here's a warning. This is the hardest mathematics subject. It is very natural. You will feel uncomfortable. Okay? And you need this. I assume you know this, so I'm not going to repeat it. So we have 3 parts. The first part is counting by set theory. That's why this thing exists after the set theory. Then we count things by something called binomial coefficient. In the binomial coefficient, you will see the factorial symbol, but we won't stop here. We'll go to trinomial, quadrinomial, multinomial, and then you can expand whatever thing you can. And lastly, we will go to something very difficult. So we will start from simple thing. So if I have 2 sets, I have A or B, okay? This is set or. It's saying that if I have A or B, the cardinality, you should know what is cardinality, the number of things inside set, okay, is number of things in A plus number of things in B minus the intersection. You know this is my set A, this is my set B. How many stuff inside? It should be everything in set A, so I just draw this cross means set A, and then everything in set B, that means this region, right? But I should not double count this particular part, okay? So I need to subtract them. So it will be A what? Plus B. But this B, I also double count this part, right? So I need to subtract it back. And this double count part is exactly their intersection. So this is very trivial. But this is not our proof. So how do we prove it? It's just 3 sentences. Sentence 1, A or B is the same as A or B not A. B not A means what? B not A means this part, right? So A or B, let me clean it. This is A, right? This is, whole thing is B, right? B not A means this part, right? Then A or B is this thing, is the same as this thing plus this thing, right? Nothing special. And then, but this set and this set are disjoint. 2 sets are disjoint. We have this formula. Then this is my x. This bracket thing is my y. So this is one part, this is another part. So you split them. I'm just basically using this box. Now I have this thing and this thing. So this is x, this is y. Then what? I have this, I label it as equation star. Okay. Now I also have b. What the heck is b? B is b not a or b and a. Okay, confusing. Let's look at them one by one. B not A means this part. That means this part, okay? Alright? What is B and A? This small part. So this small part. If I OR them, give me back the B. Yeah. So I have this thing, but again, these 2 sets are disjoint. So I can call this box again. This is my X. This is my Y. So this is true for any XY. So this is true. Now I have this, I call it dagger. So this symbol means dagger. Yeah, really a dagger, okay? I now consider star minus dagger. So you can think of this. I put a minus sign here and put a super big line here. So this part subtract this part and this part subtract this part. This part is A or B minus B, right? What about this part? The thing on the top subtract the thing on the bottom. They both share this guy, right? So I can remove them. So here I will have A minus B and A, right? So A minus B and A. What I want this. This is what I have, right? I just put this part, add to this side, I get the red box. Done. So therefore, to prove this red box, I just have 3 sentences. Now, what about A or B or C? Okay, let's look at the picture. I have A, B, and then C. I want to count this, so I have double counted this part, and this part. These 3 parts have 2 sets overlap with each other. So I double counted them twice. So that's why I have to subtract them. What about this part, okay, this part? This grid part. This grid part, I have double count them for AB, but I also double count them for AC. I also double count them for BC, but I also triple count in ABC. So in the end, you need to add them back. This is the first thing you need to know. And this is not just mathematics. This is also programming. This is called divide and conquer. What I did here is that I proved something for 2 sets. Now I have 3 sets. You try to use what you got previously. So this is 3 things, right? It doesn't matter. I add a bracket here. Now I have 2 things. I have 2 things, right? Then red box apply. This A is this A. This B here is now this bracket. So now red box said I will have plus minus 2 term plus 1 term minus. So plus 2 term plus 1 term minus. Just make sure you know which is the A and which is the B. So now you get this. And then what? This guy is red box, right? A or B, right? This is B or C. I use the red box again, so the red term becomes the red term. Now I have this thing equal to this, equal to this, equal to this, equal to this. It's the same as I don't see the thing in the middle. I don't care, right? In the end, I equal to this. This part, the blue thing, equal to this long blue thing. Then what? Now I have the blue thing. This is De Morgan's law in Z or De Morgan's law in logic. Then I apply it to here. I use the blue to replace this blue, so I get this blue. Then I now have A or B or C equal to this minus this, which is just this 4 term. I do nothing. I only change the last part. I get this one. Oh, what is this? Red box again. Now I have a bracket or another bracket. So I have this. I apply the red box. Give me 3 term. And then there are some subtraction. This becomes subtraction. This becomes addition. So now I make sure the sign is correct. And also here, A and B and A and C is this, right? Because I can swap order. A and B and this I can swap. I get A and A is A. So therefore I have this. So this whole thing becomes this thing. So what is this? This is actually what we want. So this is for 3 term. Now you see the pattern. I have 2 term. I have 3 term. What about if I have 4 term? You do the same thing. So I put a bracket. Now I have 2 term. Use equation 1, which is for the 2 term. I get this long thing. This is what? 3 term. So I use equation 2. I make it even more longer. And then what? Now I simplify the stuff. Okay, I skip the detail. You get this long chunk of thing. Okay, what's the purpose here? This is an illustration on something called recursion. And this is how you should solve problem. You see a very complicated problem. You should break it smaller. Solve the small thing and then go back. Do not direct attack the problem. This is true for anything, not just computer science, mathematics. If I have empty set, there's nothing, right? So the cardinality is 0. If I have 1 set, the cardinality is 1. If I have 2 things, it's this. And if I have 3 things, I just show you, it's this long pieces of thing. And I have 4 set, I have this even more long piece of thing. And if I write down their number as the number of terms in this expression, you see this triangle. And then now, suppose I consider something you learned in high school, you will get this expression. Magically, the coefficient and this look at the same thing. Later on, you will count stuff by multiplying polynomial. And this is very powerful. This slide have 3 meanings. Number 1, counting these 2 things are the same. Magically, something working in the background telling you, oh, if I do this, the coefficient give you the number of set here. Okay, number 1. Number 2, this kind of number, 1331, 14641. If you learn binomial theorem in high school, you know these are binomial coefficients. Number 3, this kind of triangle table have another meaning. So, therefore, all the things come together. So this is just a preview. So this, whenever you see a slide saying not in exam, you can ignore it. So what the heck is this? So this is for 4 set, right? What about 5 set? If you have 5 set, you will have plus, minus, and then you have a 5th term. And if you have 6 set, you keep going on. And if you want to write that in a very fancy, simple, try to scare other people, you write this. Okay, so this is what? If you learn how to move from 2 set to 3 set to 4 set, you know what this means. Writing this is just to scare other people. Okay, then what about this? This actually is something we learn later, So now we start. So what is counting? Just list everything. So it is a fancy name of brute force, it means enumeration. So for example, I have a length 1 string. What is length 1 string? That means I have a string. What is a string? Programming. A, B, C, D, E, F, G, simple, question mark, equal sign, 1, 2, 3, 4, 5, 0. All these are letters, so they are called alphabet. And string means a list of alphabet. Length 1 means you only have 1 letter. So if I have alphabet 1 to 7, that means in this particular world, or in this domain of disclosure, or this universe, I only have 7 objects. 8 does not exist, 9 does not exist, 0 does not exist, A does not exist. All the A, B, C, D, E, F, G, question mark does not exist, only have 7 things. Then it's saying that from this universe, how many length 1 string are there possible? What is the brute force? You just write all the possible way. Okay, then you count. There are 7 things, right? 7. Easy. But what if in another universe? In a universe, okay, this is in a computer. Let's say you are now living in a computer. So you only have symbol 0 and symbol 1, or alphabet 0 and alphabet 1. Now I want to form a length 3 string. What is brute force? 0, 0, 0, flip the first guy, flip the second guy, flip the third guy, and then flip 2 of them at the same time, and flip 3 of them at the same time. 8. Okay, then what about if I have A, B, C? And then I want to form a length 3 string. You see, if I have 3 alphabet and want to form length 3, immediately brute force become not possible. So that means what? This is the stupidest way, but you need to know. Sometime, let's say in exams, sometimes you don't know how to solve a problem and you have half hour left. And okay, you can brute force. You should not do brute force because there should be a better way. And let me tell you, all machine learning are basically a smarter way to do brute force. So what is the better way is to draw a tree. What is tree? We learn later in graph theory. You just think of it as what? A graph without loop. And in the graph theory, it's called cycle. So tree means no cycle. So this looks like a tree. If you rotate this figure 90 degrees, you have a tree. Okay, so that's why this is a tree. And then now this sentence in bold is very important. You are a computer science student, so please grow a tree in your brain. That means what? Whenever you count, the first thing to do, imagine a tree. The idea is you grow a tree. It does not need to be precise. You just have a rough idea of what the tree looks like, and then what? I said, divide and conquer. You first grow the biggest trunk. This gives you the biggest trunk in the tree, and then you refine the small trunk. In the end, this tree will give you the whole solution. This is divide and conquer, and this is also recursion. So, how do I solve this problem? I want to form a length-free string with letter from ABC. So, I will have 3 question marks. That means unknown. Then I first grow the big trunk. First letter is A, first letter is B, first letter is C. That means what? At this moment, imagine your tree is just this. Yes, this is the first step in your brain. What I'm saying is that you need to be able at least do this. I'm not saying, oh, in the 0 second you get this tree. Impossible. I'm saying in 0 second you should be able to get this. Then what? Now you should know what I'm going to do. This animation is important. First I have nothing, and then I grow to 3 things. What is this? I have 3 options in my alphabet. So I have 3 branches. This 3 has a meaning. It means I have 3 stuff here. Then what? Every time when I move, I have 3 stuff. So this 3 has a meaning. This 3 comes from how many things here? And then what? I have length-free string, right? It means I move 3 times. So that means why there's 3 branch? Because I have 3 letters, 3 alphabet. This is the first time I move. This is the second time I move. This is the third time I move. I move 3 times. Why I move 3 times? Because I have length-free. So therefore, the size of this set cardinality is 27. It's 3 times 3 times 3. First of all, 3 times 3 times 3 is primary school. But the meaning is not primary school. For example, I ask you this question. If I have a length 4 string with alphabet 1 to 7, how many strings are possible? The answer is 7 to power 4. Why? Because I multiply 7 4 times. It's the same as I move this 4 times. And every time when I branch, I have 7 ways to branch. This is the idea. The math is easy. The number is easy. Okay, let me tell you, combinatorics, very likely, you go to exam, you sit in, and then the question is just 1 line. I ask you how many ways you can do that, and the answer is probably some very simple number, but you have to stuck there for half hour and you don't know how to find it. That is, if you don't understand this thinking process, you are not going to understand this subject. Okay, so therefore, if I have an n set, that means what? I have a set with n alphabet. A, B, C, D, E, F, G up to n. I want to form a length k string. So I branch the tree how many times? K time. How many branches in each time I expand? N thing. So this is the idea. From this idea, Cartesian product. What is this? Choose one from P and Q is the same as I choose one from P times Q. Suppose I have breakfast, lunch, dinner. These are the possible things you can do for breakfast, possible thing for lunch, possible thing for dinner. How many possible daily meal you can have? Then how many number here times how many number here times how many number here? That's it, 24. This is very simple. Come on, 3 times 4 times 2, primary school, right? But the idea is not primary school. Okay? And this process, I have a cross, right? You know what? This is also Cartesian product. This is a Cartesian product of a set on itself. So this is a P times Q. These 2 sets are different sets. What is this? This is a set. This ABC Cartesian product itself 3 times. So it's also Cartesian product. So understand this. And more example. Suppose I have length 4 string over alphabet 0 to 9. And interestingly, first letter cannot be 0. Then how many things? Cartesian product. I have what? 4 objects. So you can think of it as what? I have a 1 box, 2 box, 3 box, 4 box. Each of this box is what? Is a PQ thing. So I have a box 1, box 2, box 3, box 4. I call it A1, A2, A3, A4. And because of this Cartesian product, counting, this is 2, right? Now I have 4. So I will have a Cartesian product of 4 things. Cartesian product of 4 things. And I just need to identify how many stuff here, how many stuff here, how many stuff here, and how many stuff here. Since the rule saying that the first letter cannot be 0, so this guy cannot contain 0. So this guy is just 1 to 9. So there are 9 things. There's no other rule saying 2, 3, 4 need to be special. So I can use any letter here, 10. Therefore, 9,000. So this is how you get 9,000. Then what about this? How many length 2 string over the alphabet 0 and 9 do not have repeated digit? So that means you cannot have 1, 1, 2, 2, 5, 5, and so on. So if I do not have this constraint, then I have 10 times 10. I have 100, okay? 00 to 99, so 100 number. But now, if I suddenly have this constraint, I have how many? 10 times 9, 90. So this is how you think about it. You first construct a Cartesian product, think about how big is this guy, how big is this guy, and when you think about how big is each of the set, you are actually fulfilling the condition. So first, have no constraint, because repeated means you have to start at the second A2. And that's how you get 90. And then what about this? String 4, string of length 4 with no repeated digit. First guy have no constraint, so all letter. Second guy cannot repeat the letter used by the first one, so -1. The third one cannot repeat previous 2, so -2, and the same. So you get this. So this number is how many possible string for this. And then in the beginning, I talked about this, right? This is called inclusion-exclusion principle. And if we only have two sets, this thing have a fancy name called sum rule. So suppose you go to restaurant, the menu have 2 soup, 4 salad, so you calculate this, so you have 6 choices. And this is easy. What about this one? Well, this one is 3 sets. A is a singleton, B is 2, 3, C is 3, 4. How many possible A or B or C there? There are 4. How do you solve this? If you use brute force, you write all of them. If you do this inclusion-exclusion principle, you write down a formula. This is what? This is with 3 sets. I'm very sure nobody remember this equal sign. This is the formula for 3 sets. You don't remember. I don't remember either. But I know the 2. So what I'm going to do, I just add a bracket. Now this become 2. We apply this again and again. So this is what I mean. Don't underestimate adding a bracket. Adding a bracket seems very innocent. No, adding this bracket makes you able to do this. So this kind of thing, sometimes some mathematical operation, very innocent, but they are deep meaning. And it's important to know the meaning than the actual calculation. Got it? Okay. So if I apply this, this is what? Inclusion-exclusion principle for what? For 2 sets. The first guy, the second guy, and okay, this should be subtraction. But okay, anyway. And then I make it correct in the end. Okay, but anyway. Then I get this, and then so on. Okay? Or you do it brute force. And then because we have a subtraction here, so we can have something called subtraction rule. So if I have a set A, which is a subset of a bigger set S, so this A is a subset of S, and S is called a superset of A. Okay, then the complement, you write this notation. It means what? The complement of A under the universe S. Okay, and how big is this? You just add a subtraction. I didn't prove this formula. How do you prove it? You use this formula. Then here's the example. How many subset of X? So that means 1, 1, 2, 1, 3, or empty set contain at least 2, including 2 elements. So these are the power set of X. These are all possible subsets you can get, right? I want at least 2. So this is okay, this is okay, this is okay, this is okay. So I have 4. This is brute force. What about if I use this formula? Then here, I have my S. S is P subtracting what? The size, this guy complement. What is this complement? My S is at least 2. So complement means what? The opposite. Or logic not. Okay, negation of the proposition inside the set S. So the proposition, okay, I don't know what Greek letter the other people use, I just use P, okay? The negation of this proposition means the stuff inside you turn it to opposite. So at least 2, that means what? Larger than 2. What's negation? Smaller, right? So smaller than 2 can be what? Nothing or 1, right? So therefore, nothing or 1. So I have this set containing one thing or containing nothing. This is OR, so I can make it as an OR, and I can split it. What is this? This is just OR, okay? And then containing one thing. So these 3 things are those containing one thing. This is containing nothing. Okay. So I have this, and you count them. 4. Done. Time to introduce a funny function. This thing means what? You find the closest integer of your input. But because it's integer, you are going to ignore decimal places. You can think of it as ignore decimal places. This function is very useful in lots of programming problems. For example, so suppose you are saying that, okay, my company have some administrative job to do, and it takes 10 working days to solve this problem. And 1 week have 5 working days, but 1 week have 7 days. How many weeks I need to solve this problem? Then you need to call this kind of thing. Okay, so this is very useful for giving you integer. So here example. So floor, well, name suggests floor, go down. So find the largest integer below you. Then what about ceiling? Ceiling, find the smallest integer above you. Then what if you are exactly integer? Then do nothing. That's it. So suppose I have this number, negative 2.00001. What's the nearest integer below you? Negative 3. What about pi? Pi is 3 point something, so the floor is 3. What about the ceiling of pi? 4. That's it. Easy, right? So this is ceiling. This is ceiling, okay? How many integers n1 to 2001 are divisible by 3 or 4 but not 5? This is a very typical Olympic math for primary school. So how do you count this? The answer is 801. How? Suppose I have a set n. N is a set of what? Natural number. 1, 2, 3, 4, 5 up to 20. How many integers in this set are divisible by either 2 or 3? So that means I have a universe. This universe is 0 to 20. This is a set in this universe divisible by 2. This is a set in the universe divisible by 3. How many is A or B? You need to count how many A, count how many B, subtract the double counted. Okay, so A is divisible by 2, B is divisible by 3, then you do what? Inclusion-exclusion principle. So how do you get the size of A? You have 20 number, you divide by 2, you have 10 number. This refers to how many even number are there. So 10. What about B? So if you have 20 number, you divide by 3, it gives you 6 point something. You take the floor, it gives you 6. It means there are 6 number divisible inside 20. Okay, and then now you have A and B. Okay, now you need this A and B. This A and B is what? Divisible by both 2 and 3. So it's divisible by 6. So that means you have 20 divided by 6. It is 3.3 something. So the floor is 3. So therefore, how many number? 10 plus 6 minus 3 is 13. Or you use brute force. But if you use brute force, you cannot do for this one. You have number 1 to 100. Not divisible by 2, 3, 5. Okay, A is divisible by 2, B is divisible by 3, C is divisible by 5. So this is what? Inclusion-exclusion principle for 3 sets. I have this long formula. If you forget it, doesn't matter. What? Add a bracket. Then you do it in 2 ways and then do it step by step. Okay? But now I jump, I have this, then what? Now you have a long expression. What you need to do? Write down the definition. A is all the number divisible by 2. How many of them? 50. All the even number, right? So 50. What about B? All the number divisible by 3. So 100 divided by 3, floor function, 33. Same for C. What's next? A and B means divisible by both 2 and 3. So divisible by 6. A and C means divisible by 2 and 5. That means divisible by 10. B and C means divisible by both 3 and 5. That means divisible by 15. This means divisible by all of them. So you have all this number. So you have 74 number divisible by 2, 3, 5. But you're asking the not, right? So this. You now find this. You know this. Of course, you know this. So 100. The size of all the number in 1 to 100. Of course, 100. Subtract this is what we have. Then 26. So this is how you can solve this kind of problem. So now I have some password system. Okay, a valid password. You need 6 or 8 symbols. So what does it mean? 3 in your brain. You have 6 boxes. Let's say 6 boxes. 6 and 8, that means you can have 6 boxes, 7 boxes, 8 boxes. That means in the step 1 this is the step 1. You first have one case, 6 boxes. Middle case, you have 7 boxes. Okay, and the last case, you have 8 boxes. So then what? You have 6 boxes. It says the first symbol must be a letter, lowercase or uppercase. That means A, B, C, D, whatever A, B, C, D. And the remaining symbol can be letter of digit. The question is, how many passwords are possible? So then I have to define the following. The first letter, I call it F. First start with letter F. And then other letter or subsequent letter, so I call it S. So first letter, how big is this set? It's just A, B, C up to the A, B, C again. So 26 plus 26. What about this? 26 and 10. First letter is an alphabet. Second letter is this Cartesian product 5 times, which is this case. What about the second length 7? This case. What about this one? This case. So now I have filled my tree. So I just need to calculate this. Therefore, I need to calculate something that looks like this. The first set is what? 6 length 6 password. First letter is an alphabet. The remaining 5 letters are alphabet or number. This is length 7. This is length 8. Then what? This is sum rule. Inclusion exclusion principle. And then I just count this. And then this is Cartesian product, so I can split them. F is 26, so 52. S is what? 26, and 10, so 62, and then 5 times. And this, and give me some number that looks like this. So that means you have this number of passwords. So that means you guess it correctly one time is this probability. And you are this many times more likely go to the street and hit by a thunder. That means what? That means length 6 passwords is enough. People say, oh, you need a password with 32 letters. No. If you really need that, that means you will strike by thunder many times. And then let's say there are some systems say that if you enter the password wrong, oh, you have 6 more times to try. Okay, let's say this is the case. So if you fail all the 6 times, we talk about it later in probability, then this is the number. And then what is the probability of at least one is correct? You one subtract, this is complement or subtraction rule, you have this number. Okay, now this number is 10 times more likely than this number, but still the power is so negative, you are still more likely to be hit by thunder. So this is saying that you can use this kind of combinatorics to count password. So that's all for the part 1. This is easy, right? Now here is the part that is not easy. First of all, this is in gray color. That means this is not in exam. But this helps you understand things, so I mentioned about it. We count things by number. Then what the fuck is number? This is number. Don't tell me 1 means 1 apple or 5 means 5 duck. No. 0 means the cardinality of empty set. We define number by set. 1 means I have a set which contains nothing, which contains the empty set. And the cardinality of this whole thing is defined as 1. What is 2? Then you may say, oh, easy, 2. I have a set with 2 things. Done. No. This 2 set is the guy coming from the first thing and coming from the second thing. Then now this set I have 2 things. And the cardinality is 2. And then now I have this. Now I call this thing 3. And so on. So that means what? That means, you see, number come after cardinality. So combinatorics is even more foundational than number theory. This is how you define number. Then you will wonder, who the heck care about this? Okay, yes, you're right. Because there are 2 kinds of number. So you may think that 1, 2, 3, 4, 5 is very innocent. The answer is no. There are 2 kinds of number. This is important because of this. I'm going to explain very quickly and then we finish the lesson. So there are 2 numbers. When you're talking about how many things you have, you are talking about cardinality. That means this symbol. Okay, I set A, I put 2 lines. This means how many stuff inside the A is a number. Okay, but now I have, let's say, an array or a list or a bunch of boxes. So I put something inside. I can put a fish here. I can put a duck here. Okay, I can put a tree here. Then I need somehow to label the position of this kind of boxes. Then I will say this is box 1, this is box 2, this is box 3. This kind of number is not cardinality. This kind of number is called ordinal. Ordinal means order. Okay, order. So you have 2 kinds of number. One is called ordinal and one is called cardinal. They are very different. And what is permutation? I will finish this soon. Permutation means the following. Imagine you have a box, you have 3 things. One is A, one is B, and one is C. This is original. Now you do something called permutation. Permutation corresponds to you put a pi. Pi is just a symbol, okay? Pi means what? Pi 1 equal 3 means you put 1 to 3. Pi 2 equal 3 means you put 2 equal 3, okay? This is just mean pi I equal j. What's a pi I equal j means? You put I to j. Okay, then here's the important thing. This box, I have 3 labels. 1, 2, 3. These are what? Ordinal. These are the permuted box. I also have 3 things. I also have 1, 2, 3. This 1, 2, 3 in red never change. They are ordinal. But the content inside change, right? So I have this S is 1, 2, 3. After I do the permutation, I get 3, 2, 1. All the possible permutation is something that looks like this. So how many permutations are there? It's actually asking how big is this 2 line. So we are saying what's the cardinality of another set. So when I have a bunch of stuff, I permute them. You should view this as now I have this. I now suddenly have a bunch of all the possible permutation. And each line here is one particular permutation. I'm asking how big is this set. So it's not this guy, it's this guy. This is one particular arrangement. This is a set of sets. So this is a set, right? This big chunk of thing is a bunch of sets inside this box. So therefore, when we're asking about what is permutation, we're asking about the cardinality of another set. And in each of these sets, we always have those 1, 2, 3, 4, 5 labeling the order of the box. They are all the same. but the cardinality now is different. This one only have one array, so cardinality 1. This one is telling you how many array. Here I have 1, 2, 3, 4, 5, 6. So permute 3 give you 6 things. It means I have 6 possible lists, but this guy only have one set. Okay, so I should stop it now and see you tomorrow.